Okay, good morning. Welcome to
FunMath number 117.
FunMath number 117. Hopefully we got this on screen right. I think we're going to have a little help from the math cat today. Okay, so we're taking a break from Art of Problem Solving's algebra book to look at a really fun problem that we saw in the National Council of Teachers of Mathematics. That's what NCTM stands for. On the NCTM Facebook page yesterday. And this is a problem we've talked about previously, earlier in the year. It was kind of a neat idea. And it's one of my favorite problems, or kind of problems from when I was a kid. And the question is, find the number of positive integral factors of 60 to the 5th. Do you remember when we talked about this?
Yeah, in the beginning of the school year.
Yeah, we did. Okay, so what do you do to solve a problem like this?
Well,
what's the idea? What's the sort of general concept?
We need to find the prime factorization.
You got to factor into primes.
Well, 60 equals 2 squared times 3 times 5.
Okay, how did you figure that out? Okay, yes, the math cat agrees. 60 is 2 squared times 3 times 5.
Well, it's 30 times 2.
30 times 2.
And 30 is 2 times 3 times 5.
Okay, great. So let me just write that over here so you have a little more room to write. 60 is 2 squared times 3 times 5. Okay.
So 60 to the 5th, which is...
Okay, so now we got to factor 60 to the 5th.
60 times 60 times 60 times 60 times 60.
Okay, so 60 to the 5th means 5 copies of 60, all multiplied together. Okay?
Which is, it's 2 squared times 3 times 5 times 2 squared times 3 times 5 times.
Okay. So 5 times. We get 5 copies of this all multiplied together.
Well, which is going to end up as 2 to the 10th times 3 to the 5th times 5 to the 5th.
Okay, so let's work backwards on this. Why do I have 5 to the 5th when I multiply 60 together 5 times?
You've got these 5 times.
Okay, I get 5 5s, 1 from each 60. Why do I have 5 3s?
Because you got 1 3 from each 60.
And why do I have 10 2s?
You've got 1 2 squared from each 60.
Okay, so how many 2s does each 60 have?
There's 2 2s.
Yeah, it's 2 2s, and I get that 5 times. So 60 to the 5th, it turns out, is 2 to the 10th times 3 to the 5th times 5 to the 5th. And there's actually a power rule. Oh boy, this eraser's not so good.
Yeah, it's gunking up the board.
Yeah, it's gunking up the board.
We need more new whiteboard pen.
Yeah. There's actually a rule, there's a power rule for multiplying powers to powers. Sorry, got tongue-tied. But anyway, we'll talk about that, or we have talked about that in a different time. So we factored this into primes. So 60 to the 5th equals 2 to the 10th times 3 to the 5th times 5 to the 5th. What do you do now to figure out the number of divisors?
Well, you add 1 to each power and then multiply them together.
Okay, so that's the formula, but why does that formula work? What are you trying to do to think through the divisors of 60 to the 5th?
We make a little grid for only 2 powers. There's a box for 3.
Okay, so we can think of we have choices we're going to make for how many 2s we want to use, how many 3s we want to use, and how many 5s we want to use. So what can you tell me about divisors of 60 to the 5th?
Those are going to have 2 to some power.
There you go.
Times 3 to some power times 5 to some power.
Okay, so the divisors of 60 to the 5th are all going to have a 2 to some power? And what can that power range from?
It can range from 0 to 10.
Okay, it can be 2 to the 0, which is just
1.
Up to 2 to the 10th. What can the powers of 3 range from?
0 to 5.
0 to 5?
And 0 to 5.
0 to 5. So we have this box that has how many choices for our powers of 2 inside the box?
It's got 11.
11. It can start at 0 and go up to 10, so it's got 11 choices this way. 0, 1, 2, all the way up to 11. It's for the powers of 2.
All the way up to 10.
Oh, sorry. You're right. All the way up to 10. Powers of 2. Now, how many choices do I have for the power of 3?
You've got 0, 1, all the way up to 5.
Okay, how many is that?
That's 6.
Okay, so my box is 6 high. So that means I have 6 different choices I can make for the power of 3. 11 different choices I can make for the power of 2. Now how many different choices can I make for the power of 5?
Power of 5.
Okay. Show me where the powers of 5 might be on my little solution space box.
You can put them here.
Okay. 6 choices for the power of 5. Okay, so if I can make 11 choices for the power of 2, 6 choices for the power of 3, 6 choices for the power of 5. So for example, I might pick 2 to the 5th times 3 squared times 5 cubed as an example. Okay. But I have lots of choices. 11, 6, and 6. So how many total choices do I have?
You have 11 times 6 times 6.
Okay, why don't you figure out what that is?
Well, it's 36 times 11. 360, 36, 396.
We have 396. So if we think of our box as being a big grid, a 3-dimensional grid, each block in our grid would be a divisor of 60 to the 5th. And there would be 396 of them. Pretty neat, right?
Yep.
Cool. High five. Okay, so that's a fun concept from number theory. The neat thing, you know what the neat thing is?
What?
We don't even know what 60 to the 5th is. We never wrote it down.
Yeah.
It's just some humongous number, and we know it has, without even knowing what the number is,
It's got 396 divisors.
we figured out it has 396 divisors. All right, good job.